Okay, some already said it this morning that we are moving into a more like professional part of the conference. Still 3D printing related and everything, so no worries on that. But we have someone special from the UK here, who's very experienced in like additive manufacturing, not only like the hobbyist 3D printing. So I'm curious what he has to say about his experience with additive manufacturing. So please give it up for Ollie Pocket.
Okay, so yeah, hello Amsterdam. I hope you're all having a good day. So I'd just like to start with a huge thank you to Yanis for organising this great event, to Snapmaker, Prusa and all the sponsors, and mostly to all of you guys for making it what it is today. Yesterday was a really interesting day, and I met lots of great people, had lots of insightful talks, and ate way too much Prusa cake as well, which was... And today is shaping up to be another great day. So, as Jana said, my name's Ollie Pocket, and I'm visiting this beautiful country from my home in England to talk to you today. We'll be discussing how your skills and passions put you in an excellent position to secure a career in industrial 3D printing, and how this in turn can help to turbocharge your personal projects. So I spend most of my days with my head inside a metal printing machine through the week and a plastic one at the weekends. So giving speeches like this is a new thing for me. So yeah, please be gentle with me, and I may need to check my notes quite a bit. And so yeah, I don't have the stage presence some of the other guys have. So I work for a metal 3D printing company named Alloy, based in Oxford in England. We have 2 facilities in Oxford and 1 over in Seattle in the US. It's a fantastic company to work for, and I found it really interesting over the last 3 years. So my role is operating and maintaining a fleet of 14 printing machines that use direct metal laser sintering to produce parts for many different industries, including wearable technology like frames for like augmented reality glasses, rocket thrusters, heat exchangers, and custom jewelry from like platinum and gold. Unfortunately, I can't share any videos of like the really cool stuff because obviously it's all very secret squirrel and that, I'm afraid. But I'm not here representing Alloy today. I've come in my own time as a fellow maker to talk to you about how your hobby puts you ahead of the pack when applying for a role in industrial additive manufacturing. So a few months ago, I stopped at a motorway service station, and in case you didn't know what they look like, there you go. I was browsing the shelves for a sandwich to help me get through a long journey when I overheard part of a conversation between a young employee behind the counter and his colleague. And he said that classic line that we all love. He's like, "I've got a 3D printer, I'll just print you a new one." So when I went up to the counter to pay for my sandwich, I struck up a conversation and we geeked out about our printers and home projects for 20 minutes. Then I mentioned that I work in industrial AM and explained a bit about it, and his eyes just like widened, you know. He was like, "Wait, I could get paid for this?" Like, and he looked around the service station. You could see like the cogs turning in his head, and it was almost like he'd just found a cheat code. So now I'm not going to stand here and tell you that industrial 3D printing is the best job in the world. It can be very tedious and boring, and sometimes there can be a lot of protective equipment to wear. But if your day job's working in an office or stacking shelves in a supermarket, or like this guy working in the service station until your 3D printing business takes off, then I believe it's 100 times better and will help you in your personal projects 100 times more too. So the industry just doesn't know how to find you guys, so today I'm here to sort of recruit you for them. So who has ever spent more time fixing their printer than actually printing, or had achieving a perfect first layer become your personal Mount Everest? Or maybe your mesh leveling scan of your bed looks more like Mount Everest. Or have you ever tried to explain infill to someone who really has no interest and just wants you to print like the damn Pokemon? So good news, those frustrations, they're your golden ticket to a career. That time you rage quit after a 20-hour print failed at 95%, that's called stress testing. And the hours you spent arguing about print file parameters on Reddit, that's materials research. And here's the best part, there are companies that will pay you to do very similar stuff. And this, obviously, it happens to the best of us, yeah? This is what we in the industry would call a thermal management learning opportunity. And if you can explain why it happened, you're already ahead of most of the entry-level candidates. So today, what I really want to do is explain, how you could turn your hobby into a career that in turn will fund and give you the skills to supercharge your own projects. So industrial additive manufacturing sector is exploding, but they can't find enough people who know how to run the machines. The AM industry is worth $20 billion and growing 20% yearly, but 60% of companies say they can't find the skilled staff. Meanwhile, there's an entire army of experts hidden in plain sight. You, the hobbyists, the makers, the folks who've mastered bed leveling at 2 a.m. or who speak fluent Octoprint and who've turned failed prints into featured designs. Companies want people who failed prints because you understand why things fail, and your skills, they're gold dust to these guys. A hiring manager said to me recently, I'd take a hobbyist who's rebuilt their hot end over a PhD who's never touched a printer. And so that's where you come in. Companies aren't looking for PhDs for operations roles. They want people who've wrestled with warp beds, perfected the cold pool, know that just add glue stick isn't always the answer. And industrial AM isn't some mystical realm. In fact, operating and maintaining the machines is often easier than desktop printing. These machines are beasts, but they're beasts with actual tech support and a team of service engineers who can be on site the next day, which, considering most of the machines cost nearly €1 million, that's the least you'd expect, really, isn't it? So industrial AM also isn't just about pushing buttons. It requires material science know-how. Why the ABS warps and cracks relates to why titanium parts crack from residual stress. Process parameter mastery, like your 200 hours tweaking slicer settings, that's design of experiment training. And metrology awareness. If you've measured a 20 millimeter cube with calipers 50 times, you're already doing quality assurance. So, as I mentioned, and you of course already know, if you get the parameters or the atmosphere conditions wrong, then FDM parts made from certain plastics are notorious for cracking apart from stress, like this yellow cube. And as you see on the top right, this is something we know all about with the metal parts we produce, and it causes engineers many sleepless nights. There are many differences, of course, but it's a great starting point, and it really helps to be able to understand what the engineers are trying to achieve, having that base knowledge already from polymers. Everyone's familiar with the struggle of getting a nice first layer in FDM. Well, it's a similar struggle for people working in direct metal laser sintering. If the first layer spread of metal powder is too thick, then the print will warp and peel off the substrate in much the same way how the plastic does when your nozzle's too far away from the bed for your first layer. And that perfect first layer obsession, in metal AM it's called ricotta blade gap optimization. And it's the same drama, just a fancier term. Most metal builds need to be put in a furnace after printing to relieve stresses. And if you're post-curing your resin prints, that's basically stress-relieving metal parts, just with UV instead of an 800-degree furnace. And it's the same way of thinking, just on a different scale. And of course, a lot of companies now use FDM and SLA machines for internal tooling, jigs and fixtures. Like in this picture, you can see the red part, which is a custom fitting that we used to hold a watch casing in place while it's being CMM inspected. And at Alloyed, we don't sell parts made from plastic, but we have 12 desktop FDM machines and 3 SLA that are working flat out across our 3 sites. So if you could jump straight onto those machines and work them without even needing training, it's a big plus for your chances, and even better if you can fix them too. And something that's always surprised me with these companies is how little some of these incredibly intelligent engineers know about other types of AM, than the one that their professional field. A lot of the metals experts just don't have the first clue about plastic printing. So at Alloyed, we struggle with the dosing and spreading of the metal powder, making sure there's enough material each layer and it isn't underdosing. If you watch this video, you can see a small amount of fine metal powder is released, and then the ricotta comes across and wipes a thin layer across the build plate. After this, the laser fires and pretty much welds a layer to the metal build plate. Then the build moves down in the Z-axis by 30 microns, and the process is repeated over and over, building up the parts layer by layer. Sometimes you don't get enough powder spread uniformly across the plate. And it's like with FDM, when plastic can under-extrude because of a number of reasons. I certainly don't need to tell you guys that. But you have to work your way through a list of potential causes, ruling out each one until you solve the problem. And this kind of mindset is exactly what companies are looking for. A common cause of print failure can be down to material health. Some plastic filaments are very susceptible to absorbing moisture from the environment, and some are negatively affected by UV light, so need to be stored and looked after carefully, just like resin for SLA prints. And this is much the same thinking when dealing with metal powders. There are different reasons for poor material health, but if you keep the metal powder in a sealed container, keep a constant temperature, reduce exposure to oxygen and moisture, you're going to have a much better time of it. And if your build does fail, you can save lots of time with your diagnosis of the problem if you can already rule out a few potential causes. Support removal requires similar skills across most types of additive, but thankfully with plastic there isn't so much of the personal protective equipment and fine powders you could breathe in and stuff like that to worry about, but it still requires a great deal of skill to remove supports without causing damage to the parts. And one last similarity, over-extruding in FDM is the same in metal AM with overbuilding, which can be caused by poor printing parameters or poor material health. So I hope you agree there's many similarities. I think that as the industry struggles to find people with the skills to operate AM machines, that looking towards this community for at least a part of the answer is the way forward. If you've tuned retraction to fix stringing, you can understand the process to optimize laser parameters for metal. Both involve swearing at tiny imperfections no one else notices. And your 0.16 versus 0.2 layer height debates, in DMLS we argue over 30 micron or 45 micron layers and how it affects the grain structure of the metals. So if you're juggling multiple Creality printers, well, that's workflow optimization on your CV. You've got the multitasking chops to manage an industrial AM floor. My friend's Ender 3 farm taught him more about batch production than his engineering degree. And you know how PETG needs different temperatures than PLA. Well, that's the foundation for understanding Inconel 718 versus titanium 64 print parameters. Why aluminium alloys need heated build chambers. And like I said, how moisture affects metal powder, like it ruins your nylon filament. So, let's talk money. My first AM job bought me an Ender 3. My second, Elegoo Mars, and my current role, well, let's just say my garage now looks like a university makerspace. This isn't just about buying new toys though. That salary funded my trip here to Amsterdam. It's funding my future business, and it will fund yours too. Whether you dream of printing cosplay armor, or launching a prototyping studio, or even becoming a 3D printing influencer like some of the fantastic people I've shared this stage with. So, over the border in Germany, you can find some of the highest salaries in Europe, especially for senior roles. A lot of companies also offer 13th and 14th month salaries, and there's some senior applications engineers are on over 100k. An AM technician at entry level would be looking for 32 to 40,000 euros, an experienced one 40 to 50, and an AM engineer at entry level would be 40 to 48,000, experienced 48 to 80,000 plus. And here in the Netherlands, salaries are a bit lower than Germany, but the 30% ruling means a big chunk of your income is tax-free if you relocate here. And there's also a mandatory 8% holiday bonus on top. AM technician entry level, 30 to 38,000 euros per month, and an experienced one 38 to 48. And an engineer entry level 35 to 45, experienced 45 to 65 plus. I'd like to take this opportunity to thank my friends at Hearns Head Recruitment for helping me out with these figures. They're a recruitment agency who specialise in 3D printing, and they sort of represent some of the big companies across Europe. And if you'd like to talk to them about potential roles in the industry, come and see me at the end. I'd be happy to introduce you to them. But, you know, they're not paying me or anything, so it's up to you. You know, I don't mind. We also have several roles currently open at Alloyd if you live in or would consider a move to England, and I'd be happy to share them with you and have a chat as well. So I wasn't some engineering prodigy. I worked in many jobs across many sectors before finding my home in 3D printing. I was actually quite set on becoming a chef at one point in my life and went to college and studied it for a couple of years while working in a restaurant. Unfortunately, I was a very angry chef, and it was a very stressful job. I didn't have Gordon Ramsay's talent, but I had his temper, you know. And I think if I was still in it today, I probably would have had a heart attack by now. So I started with an ANET A8, if anyone else used to have one of those. And it caught fire twice. So I learned about electrical safety the hard way. And then I learned how to download and slice files from Thingiverse, then how to CAD my own models, and I was hooked. Then an AM engineer changed my life. He'd been helping me get to grips with the ANET and was impressed with how quickly I picked it up. And he said, well, if you can run this thing, you can run an industrial machine. And I thought, well, me, work with metal printers, laughed at the time, but he was right. He was setting up 2 Renishaw metal printers for a company and had nearly finished with the parameter development. And it was about time to go into production, making customer parts, so they were ready to hire a 3D printing technician to operate the machines. So with my friends back in and my FDM knowledge, I managed to land the job of additive manufacturing technician. My first week on Renishaw machines, I learned that metal powder is 100 times worse than glitter for just getting it everywhere. Personal protective equipment is non-negotiable, so there was no more printing while just wearing my underwear I like at home. Sorry for giving you that image. From there, I moved to a company at the racetrack in Silverstone, and I was printing F1 wind tunnel parts on an industrial SLA machines. And you know, people who do SLA printing, when something fails and you have to sort of sieve out all the bits, well, you can imagine what it's like when you have hundreds of litres of resin to sieve from like a huge vat. It was quite an experience. Wind tunnel models for Formula One motorsport taught me speed matters, but not in the obvious way. The time frames to get the parts printed, de-supported and post-processed were crazy. But it also taught me surface finish isn't just cosmetic. A 5 micron RA roughness versus 15 affects aerodynamics massively. And due to the nature of Formula One industry, if you manage to secure a role in this sector, please be forewarned, you can expect late nights and long weekends, hence why I left after a year in the role. But I did manage to get experience before leaving, operating industrial SLS, SLA, FDM, DMLS, ABCDFG, and that experience will be critical for my own business ideas when I'm ready to make that leap. And now I work for Alloyd, operating the machines, post-processing the parts, scheduling the builds, and leading a small team of technicians. I tell people proudly that I work with rocket thrusters, but I still go home and mess up printing PETG at the weekends. But this isn't a one-way street. I've always been comfortable with machines and with coming up with ideas, but selling my ideas and public speaking has always held me back. In my job, I've held meetings with directors and CEOs, given presentations to whole company events, and represented the company working on the stand at conferences and trade shows across Europe. And this has given me the confidence to stand in front of you today, something I couldn't have dreamed of doing 2 years ago without anxiety taking over and having a massive panic attack. So I've got money in the bank, skills at my disposal, and connections across 3D printing. And with the skills and salary I've gained over my career, I'm now in a great position to follow my dream to start my own company. I'm very interested in making high-end interior design items like light shades, lamps and vases, but from recycled materials. There's a company in the UK named Fishy Filaments that make filament from recycled industrial fishing nets, and then that would otherwise end up dumped in the sea or thrown into landfill. And I think if I can open a shop near the coast and the seaside, and you can actually see the fishing boats from the shop, this would be a big selling point. I want to spend the next year working on this plan. I'm going to take a course in interior design. I need to work out what would be the best printer for this material, as I'm pretty sure I'm going to need an enclosure to print nylon successfully. And I need to research where would be the perfect coastal town for this. But thanks to my career, I can afford to do this. It's certainly not my dream to be running printers for somebody else for the rest of my life, but it's great for me right now. So, homework. Rebrand your resume. If you fix clogs, you've resolved extrusion issues. If you're juggling multiple printers, put it down as workflow optimization experience. Think about how you word things that would stand out to potential employers. And build a portfolio. Show your failures, and more importantly, your fixes. Show your next employer that you have the problem-solving initiative they are looking for. And network today. This amazing event is a great opportunity to network. It's very rare to have so many great minds from the world of 3D printing in one place. And also consider signing up to LinkedIn and build your connections there. I know it can be pretty boring and cringe on LinkedIn, but it's also where I found my last 2 jobs. And also find me after and I'll share recruiter contacts and you can tell me about the cool projects you're working on. So, in conclusion, you don't have to choose between passion and paycheck. The industrial AM world is begging for people like you, hobbyists who treat prints like puzzles, makers who see failure as R&D, and tinkerers who'd rather calibrate than sleep. Take that skill set, land a job, and let them pay for your next printer. Let them fund your side hustle. And when you're ready to go solo, you'll have the experience, the network, and the cash to make it happen. So why choose between hobby and career? Why not both? Thank you.
Fantastic. Watch our project zoom.